How long should you wait before waterproofing over a screed? This is the topic for today's Sealed for Good, and there's a lot of interesting content in this one, so tune in and pay attention because we're going to cover a lot of things that come up daily for many of our customers out in the marketplace, and also for a lot of builders out there to understand the challenges they have with the surfaces they've got and what your applicator is confronted with on a daily basis. So these are common questions that come up from applicators many times. We get lots of questions about the tight schedules and demands from their building clients about going over a green concrete slab or a damp screed particularly. And the question is always about how dry is dry enough, and is there a difference between a screed or a concrete slab that they're going over internally versus externally. Now, there's an arbitrary figure that the industry uses and many of manufacturers will have in terms of what is deemed as the correct curing time for a concrete slab, which is normally 28 days, and for a cement-based screed, 7 days for curing before you can go over it officially. And over this period, what happens during that 28 days and 7 days respectively is you get most of the moisture is evaporated out of the surface, so if there's any shrinkage cracking, it's likely to have shown up or occurred during that time. Residual moisture has gone, or you've got very limiting effects there that are retained. And also you've got an acceptable surface now that's ready for toppings, a la a membrane substrate or tile adhesives or self-levels, etc. But however, temperatures, the relative humidity, the application over traditional type Bondec concrete slabs with formwork, application of screeds over a membrane, when you've got to go directly over, bond a screed directly over a membrane, exposure to rain, what that can cause in a concrete or screed. Externally, you're going to find that these situations can impact the moisture level of the surface, and understanding that is where it needs to really happen. It's not necessarily the moisture content that you need to focus on, but more importantly, we talk about in the industry about moisture vapor transmission and ensuring that the moisture during that curing phase, what is that level that's acceptable, and when it then allows you then to put your membrane finish over the top of it. So it's the moisture that's left within a screed, the retained moisture, that is normally going to be the cause of what we see that phenomenon with blistering membranes, which many of you would have seen with liquid membranes out on top of screeds, and also potentially the delamination of membranes off of a screed because of the residual moisture. And this happens worst case scenario externally more so than internally, but it can still happen internally. I've seen that happen. So the argument is, if you've got a slab or a screed that's wet but has a low water vapor transmission, will the membrane still bond and not delaminate, as the rate of evaporation is not sufficient to sort of make the membrane dislodge or debond? This is a weakness in our industry, guys, and we talk about, I've had a harp on this before about AS 4858, 4654 and other standards, but there's no current standard in the liquid membrane or the waterproof membrane market in general, in those two, that actually talks about the acceptable moisture or vapor transmission level for applying liquid membranes over a surface. Now, we see 5 to 8% moisture content is typically deemed acceptable, but that can also be determined by how you measure that moisture. And so if I talk about our flooring friends in the flooring game, particularly with timber flooring and vinyl flooring, but parquet and timber flooring particularly, that is an industry I respect a lot when they actually measure moisture, because they normally use a hygrometer or they have a moisture meter, and if it's not at a certain level, they will then have to take precautions to prepare that floor. So what you have is the resilient flooring industry has a standard that they go to, and we don't in our waterproofing game. We tend to sort of skirt the issue, or around about, or close enough, and this whole near enough nonsense that I've been talking about before is not good enough. We need to know what it should be and have that parameter set and be very clear in how we measure it. So from our experience, blistering and pinholing is definitely seen more with external applications more so, and that's because you've got a greater water vapor transmission rate happening because you've got the external surfaces. You've got sun on a membrane. Even if it's the winter months, you can be in places even like Hobart and Launceston where it's very cool down there, but a clear day with a bit of sunlight out in a membrane, and as it's going through that curing phase, it can create blistering if the moisture is trying to come through. So the risk of coating over a damp screed or a green concrete slab is the blistering, It's the delamination of the membrane. You've got prolonged curing time. You've got membrane softening, shrinkage cracking, which can occur, and that normally is mirrored with what's happening to the surface. You also have trapping of the moisture in the screed, and it's got nowhere to go, and that can create other issues later on. And then you've got the situation where you just have a substrate where you've trapped moisture between, particularly where you get over and under, where you might have a membrane underneath the screed and you're putting it on top. You can have trapped moisture there, and that creates issues to the surfaces of where the moisture is going to go. And other things like efflorescence can be formed from the prolonged curing of the way that we don't allow screeds particularly to cure properly. So what are your options? Well, where possible, waiting that curing phase that's suggested with 28 days on concrete and 7 days for screeds is the best practice, because that allows it to sufficiently dry and ensure the moisture vapor transmission rate to be as low as possible. You need to monitor the weather, particularly for external applications, because you need to understand that even though a screed might have been down for 5 days and drying, then you got rain or you got a consistent morning dew on there, that's all going to be absorbed back into the screed and contribute longer. I do suggest that we start to get into the practice in this industry that waterproofers have moisture meters on them. It's a very low investment. You can get a good moisture meter between $300 to $1,000 and actually know those substrates, like the timber flooring guys have, because by having that you can be certain that you can mark off, show your client what the situation is, and come back to manufacturers like ourselves where we can help confirm for you if that's too much moisture in the screed for the product you're going to be using. It's good practice, it lifts your game and it separates you from the cowboys out there. And that's, like I said, I remember when I had the flooring guys at my house doing some timber flooring, even though I had concrete slab was bone dry, they were there, they wanted to test it, they had to mark it down, and that was in their quality control process. And whether they were actually writing stuff down that mattered or not, it impressed me. And I'm sure you can do the same for your clients. There's a lesson learned from other trades sometimes. So what do we do if we've got a situation where we're going to go over a screed that is damp and we've got to get the job done and we haven't been allowed that 7-day curing? Well, you've got products like our E60, our water-based epoxy primer, that can be used over the concrete, over the screed, even concrete, but over that screed, and will stop the residual moisture from coming into the membrane, and so allows you to keep the job flowing along. You can also pay attention to this point, which is often forgotten. When you're putting your liquid membrane down, even if you've got a screed that could be damp, but we're not in the real winter months, when you've got conditions overnight that will actually assist your application, you need to understand that putting a membrane on a damp screed or a screed with residual moisture in the heat of the day is not going to be to your advantage, or before the heat of the day, because what happens is the screed is warming up through the sun. This is outside, the membrane starts to skin, and those moisture vapors have only got one way to go. When you know you've got an area that's going to be in the shade for the rest of the day, or it's cooling down into the evening, that's the best time to actually tackle that part of the job, because then it's got overnight to cure properly, perfect conditions. The next day you'll find the membrane is dried sufficiently enough that it actually, and things like our Gripset 38FC, our P39, 2P particularly, are dry enough that they're not going to be impacted by any residual moisture that could be left in that screed, because they're film formed. And you're not actually drawing that moisture out of that screed as much with the heat. And I'm talking about this first 7-day period when you're going over that, because that's when you're really at your most vulnerable during that phase of when the moisture is still hanging around in the screed in that condition, that thickness of the topping. Substitute your pre-mixed liquid membranes, your one component products, with the 2-part cementitious. You might have seen an episode previously when I talked about cementitious membranes, things like our Gripset 2P, our C1P products. They're really not prone to the blistering phenomena that you get with the one component product, and they've got superior resistance to residual moisture. They have that degree of negative hydrostatic resistance as well, because often they're used in underground applications, and that's a big advantage of a cementitious system on a damp screed. And so that should be considered as well, because it will definitely help you in terms of how you allow your job to flow without having to go back and repair it, cut out blisters, rip it all up again and start again. And those products like our 2P and C1P also breathe. So what happens is, during the curing phase, the moisture in the screed of the concrete can still evaporate through without any more moisture going into the slab or the screed from there, and the drying properties of those cementitious systems will allow the job to flow, as I mentioned before. This is always a tricky one, guys. We get these questions all the time. I've given you a few gems in there about investing in a moisture meter. I think you should do that. It will definitely help your game and help with your client. But if you've got specific questions on this, our tech team are here to help on that. We have got a lot of experience with this saga. I know many of you come into the winter months now. It's an ongoing one, but it happens all year round. So don't be afraid to ask the question. Numbers on the board, 1-800-650-435. Don't forget to subscribe too, guys. I want to see that feedback coming, that content. Loving the engagement with many of you of recent times on both our Facebook and Instagram page and our YouTube channel. Thanks for joining us again. I'll see you in the next episode.